Okay, so now we're going to be looking at the effects of an increase in income. And I should have all of my notes set up now that we should be good to go for the future. For the rest of these videos, I think everything is in the right order and we should not have any needed interruptions. Yes, okay, everything is in line. So, one of the things that we are now most interested in is what happens to our demand curves when we start to change things back and forth. So when our income goes from $60,000 to $120,000 a year or something probably less drastic, but let's say that we got a $10,000 bonus. How would our demand for certain goods change? Would we be more preferable to substitutes, to complements and everything? For whatever. And so we're first going to look at changes in income by developing this thing called a co income consumption curve. So the ICC. So an increase in an individual's income, holding tastes and prices constant, causes one, an increase in the demand of the good if it's a normal good. So if we're thinking about beer as a normal good and donuts as a normal good because everybody loves a good donut, then if our income went from 60 to 70K, we should be demanding more of both. But if we're thinking of something like ramen noodles, that's an inferior good, we now have more money to spend on better alternatives, so our demand for that good should decrease, right? So a change in our income makes us choose a new optimal bundle. So we're going to be moving into a new indifference curve. And this resulting change in income and our new utility can be maximized in three different ways. So first, we can use our ICC, which is what we're going to do now. Second, we can use our demand curve. Or third, we can use this thing called an angle curve. But let's first just start with this income consumption curve. And our income consumption curve is exactly what we had drawn before when we were thinking about our price consumption curve. The only difference is that instead of changing with price, we're going to be changing with income. So if we remember, we'll draw this up here. Actually, here we can just go backwards. So our price consumption curve, if you notice, this point here, this intercept, always remained fixed. And so we just essentially pivoted the curve out and out and out. The difference is that with a change in income, we should be able to shift the entire line if both goods are normal, right? So if we have this original, actually, we're going to make this more slopey. So let's say that this was original. Let's call donuts on the x-axis again, beers on the y. Then we're going to bump out for a change in income. We're going to bump out again for a change in income because, again, we're going to be able to buy more of both types of goods. So if we want to think of this now, this was y1 over p1. Now this is y2 over p1. This is y3 over p, or these should be d's, sorry, pd's. This would be y1 over pb. This would be y2 over pb. This would be y3 over pb. Because again, each of these is corresponding to a new income, right? So we had an income increase again. But alongside of each of these, we also still have our indifference curves that are going to be sitting on these lines. Oops, we want this to be more curvy. Please. Here, we'll just draw them like this. It'll be okay. We'll draw fat lines. We want this one to be moved up just a bit. Right, so this is going to be our optimal bundle here. This is going to be our optimal bundle here. This is going to be our optimal bundle here. We're going to need this one to move up for our examples. And so we're able to draw a line very, very similarly to the price consumption curve straight out of this. And this is called our income consumption curve. And so if we think about this, right, we can call our budget line 1 should be y1 equals p1q1 or pbqb, pbb plus pdd. Our second budget line is when income increases. And our third budget line is when income increases again. And so notice the only thing that's changing are our incomes, such that all of that is true. And if all of that is true, then we're able to draw a very, very similar thing to the ICC. And then we can get into something that we like to call income elasticities. And remember, we talked a little bit about income elasticities. I think it was in supply and demand. Our income elasticity is how much does the change in our quantity demanded happen of a certain good following a percent change in income, right? And so income elasticity measures the responsiveness in our demand for a good following a change in an income. And so typically we would just look at the change in quantity demanded over our original quantity demanded divided by the change in income over our original income. But now that we have calculus, we don't have to look at just kind of discrete jumps. We can look at something more kind of impactful, and we can look at y and q, right? And so, I mean, the partial derivative with y and q. And that should help us with these income elasticities here. So, more frequently, right, we're going to look at these income elasticities, and there's a lot of different types of goods. So, for normal goods, necessities, these are things like water, beer, donuts. Our income elasticity is always going to be somewhere between 0 and 1. For normal or luxury goods, our income elasticity is going to be strictly greater than 1. Now, what does that mean? That means that for a 1% change in income, we are going to have more than a 1% change in quantity demanded, right? So, and these are going to be like really expensive things. Like these are going to be your cars, your TVs, your PlayStation 5s. For inferior goods, you're going to have that be less than 0, which means that for a percent change in income, a 1% increase in income, our percent change in quantity demanded is going to be negative, right? So let's think about this a little bit more, right? So in our original example, both of our goods were a normal good. So we had an increase in income um, in normal goods. We increased in income consumption. But what if one good was inferior, right? So what if we were able to say um, that our increase in income would lead to a lower quantity demanded in goods, right? So if we had um, yeah, what if it was just a one increase here? So we are still going to have our budget line increase, right? Our budget line isn't going to change at all, right? So let's call this, let's call these donuts again, and then let's call these instant noodles. Our original budget line, still going to be the same. Our new budget line, also still going to be the same, right? When we have, let's call this our original equilibrium. And actually, let's draw a third budget line. So let's move this one in just a bit. And then let's draw a third budget line. Right? Our budget still increases, so we still could, in theory, buy multiple inferior goods. Um, and I'm actually going to raise this up just a bit. But if we think about it, as our income increases, we said that our quantity demanded for good one would increase as well. So we would be shifting this way. But our inferior good says that we should shift this way. And so our new optimum is going to be on both of those. So our ICC is then, and again, there's indifference curves all along this. Our ICC is now downward sloping. And our ICC does not have to be a straight line, right? If we wanted to fit this actually, it could look like this. I'm just drawing it as a straight line. Sorry, could look like this. I'm just drawing this as a straight line for simplicity and for ease, but it does not have to be a straight line. All it has to do in this instance is be downward sloping, right? And so you can, and if you wanted to flip the graph as well, I wonder if there's an option for me to flip this graph. Um, no, I don't think there is. Either way, you would be able to get something similar, and your indifference, I mean, your ICC would just look like that instead of like this. You're just going to have it flip the other direction, right? So you're going to start like this, like what we have, and then let's suppose that it was the, like, we wanted the second good, I mean, the first good to be the normal good, I mean, the inferior good, and the second good to be the normal good. It would just flip like this, and we would be okay with something like that. That one you can see at page 116 if you want to see that. Cool. So now we can start translating our income consumption curves into uh, quantity demanded, right? Or here, actually, here you go. We are going to stop this share for a second, and we are going to share this screen. I forget that I have all of these notes pulled up. I'm sending you guys to all of these spots. Um, in this instance, we see that good one, good X is inferior and good Y is a normal good, right? And in here, good X is a normal good and good Y. So on the right-hand side was what we just drew, right? So we saw decreases from Y1, Y2, and Y3 in good Y, but we saw increases in good X. So we had a decreasing income consumption curve. Alternatively, if we had decreasing values of X, X1, X2, X3, and in increases in Y1, Y2, Y3, we could have an ICC that looks like this dashed line. And so we would be okay either direction. Um, let's come back to the notes. And what we have now is we should be able to derive an ICC, I mean a demand curve from our ICC. So what happens to the demand of Q1 with our 1020 framework? Right? What follows an increase in income? Well, we know that our budget line should shift to the right. Like our demand line should shift to the right. So if we think about our demand, we're going to have demand here and supply here, I think because I'm mirrored for you guys. And then we're going to have demand shift outwards. With an increase in income, our consumption is going to increase. We always know that if we can consume more, we're going to demand more, but our prices are going to remain constant because it's only an increase internally, not an increase for everywhere. But our demand curve is going to shift right, keeping all of our prices constant. So if we wanted to see this, do I have space down here? Oh, I do have space down here. Um, we are going to be able to draw first. Let's draw two plots. Okay, and then in here, let's just call this Q1, Q2. We're going to draw our budget increases. And we're going to draw, let's just make our ICC like super aggressive. And so if we wanted to, we could also throw in our budget, I mean our indifference curves. Um, then we're going to be able to drop dashed lines from each. And if we have each of these, then we know here, right, because we said that our quantity was changing, but our price is not changing. then we can translate it to be something like this, which doesn't look super informative, but if we think about what is actually happening with each of these demand curves, we have this demand curve here, and then we had another demand curve here, and a third demand curve here. Let me make sure that these are going through each of these points. And we should be able to show the natural progressions of quantity increases but price remaining constant as income increases. And that would be how you would derive your demand curve. But again, you want to make sure that these are just constantly kind of like, you just want to make sure that these things are consistent. This is more of a like sanity check than anything to be taken away from. And so now we're going to get into this concept called an end goal curve. So an end goal curve was derived from this dude who won the Nobel Prize. And an end goal curve represents income as a function of a good's own price and its quantity demanded. And so it's a relation between price and quantity. We're going to graph the end goal curve, like price and quantity is the demand curve. If we replace price with income, then we're going to get the end goal curve. And so how are end goal curves useful? So for example, suppose you're a business owner. It shows exactly how the quantity demanded of her product would change due to a change in the income of consumers. So imagine you're a small business owner and your local constituents just got a huge new tax raise or tax decrease. And so you are now able to charge, like, people are going to have more income. What is going to happen to the quantity of goods that you are going to be able to provide? In a developing country context, it shows how a big push, like a grant that it would increase income, would affect food consumption. But again, if you wanted to think of an implicit function, the angle curve is essentially just going to change y as a function of quantity and price. And it almost is like we're going to be keeping price pretty constant. So if we recall our income consumption curve, our angle curve, so if we come back up here and we have these two graphs, we know that this is budget line one. This was budget line three. This was budget line two. This was budget line one. And so each of those should correspond to changes in income. And we'll call this D instead of Q1. Right, so this should correspond to a change in budget line 3, budget line 2, budget line 1. And we said that this was D1, D2, D3. And each of those increased. And so this yellow line, the line that we've been drawing through the entire time, the ICC, could also be considered an angle curve if we were going to draw it on its own axes, right? Because budget line 3 is going to correspond to a certain level of income. Budget line 2 is going to correspond to a certain level of income. Budget line 1 is going to correspond to a certain level of income. And so now we're comparing quantity demanded into varying levels of income. Um, and each of us is going to change slightly. So essentially, we're going to plot the quantities that we found from the income consumption curve and the demand curve directly on the x-axis. Then we're going to find the corresponding, so find D's from ICC. 2, find Y's from budget lines. 3, join curves or join points with a curve. And so we should also be able to see this from the textbook, right? So we can zoom in on this instead of me trying to do it all at once. And you guys can kind of see that, look, we've got this income consumption curve. From each of these, we are going to get certain quantities that are going to correspond to beer in gallons per year, but they are also going to correspond to the same one price that when we shift to the demand curve, the price is going to remain constant, but each of our demand curves are going to shift one to the right, right? So we can see this here is that we are shifting right or up, which is good. That's a good sanity check. But our quantities, again, are still going to remain the same. And then when we shift and find the corresponding incomes related to certain budget lines, we should be able to draw the angle curve and be able to go. This example is from the textbook, so if you wanted to see it, you're more than welcome to investigate more, but just suppose that your budget increases, you hold the prices constant, consumer buys more of both goods, we see the upward slope in the ICC, demand shifts rightward, and the angle curve shifts upward, which is all that you should see. Exactly. So if we wanted to calculate this mathematically, we could also do so. Um, the steps are based on our utility maximization framework, right? So we're going to calculate the demand for the other good, and we're going to plug that value into the budget constraint here, right? So let's suppose that we are going to find our angle curve for beer given our utility function and budget constraint here. So first, let's find our donuts as a function of beer, right? So in other words, let's find our demand. When we find demand, right, we can use let's just use our MRS again, because this is super easy to use our MRS for. We're going to go UB over UD. This is going to be minus 0.75 B to the minus 0.25, D 0.25, 0.25, and then we should be able to get minus 3 over D over B. Our MRT should be minus PB over PD. And so Z, putting these together, star or D star, not Z star, my fault, should equal 1/3 PB PD times B. Second, you are going to just plug into budget constraint. So we're going to get Y equals PBB plus PDD, which then we are going to get PBB plus 1/3 PBB, because this PD here is going to cancel with this PD here. And so combining everything, we are going to get Y equals 4/3 PBB. And this is our angle curve. So we're going to take a quick recap. If we scroll back up here, when we were finding this curve here, right? And we were doing the two things, and we plugged this D star here into this budget constraint to find the optimal value here. This graph, I mean, this equation that we found here is an angle curve. That is an angle curve. We just didn't call it an angle curve, but we've been doing it since we started. And so if we come back down here from where we left off, that was it graphically, that's from the textbook, that's mathematically. We should be good to shift into the effects of a price increase. Thanks again, everybody, for watching this one. We'll catch you on the next video. Perfect.